Last one, 2.2.5, part 5. So when you talk about functions, you can talk about them in terms of where they are increasing, decreasing, and constant. If your graph is rising from left to right, it is said to be increasing. If it is falling from left to right, it's decreasing. And if it's just a horizontal from left to right, it's said to be constant. Whenever you talk about increasing, decreasing, and constant, you always talk about it in terms of x. So based on the x coordinates, what is your function doing? So you're looking at the y, but you're explaining it in x. Let's see what that means. Is f of x equals negative 3x increasing, decreasing, or constant? Well, if you remember, this is a linear function, and that negative 3 is the slope. So just based on that, you should be able to tell what it's doing. But if you don't know, since negative 3x plus 0 would be your function, 0 is your y-intercept, slope is negative 3, so you have negative 3 over 1. That means you go down 3, right 1. That means your graph looks something like this, right? So just based on that, what is this function doing? Is it increasing or decreasing or constant? It's falling from left to right, so that means this one is decreasing. Sketch the graph of each function and identify any open intervals on which the function is increasing, decreasing, or constant. So for this particular graph, let's pick some x and some y values. I think I'll just pick these. So we have 4 minus negative 2 squared. That's 4 minus 4, or 0. We have 4 minus negative 1 squared. That's 4 minus 1, or 3. We have 4 minus 0 squared, so 4. 4 minus 1 squared, that's 4 minus 1. And then 4 minus 2 squared, that's 4 minus 4. So plot these. We have negative 2, 0. Negative 1, 3. 0, 4. 1, 3. And 2, 0. So our function looks something like this. It's an upside down parabola, and it shifted up 4 units. So this particular function is rising this direction. Remember, you always read left to right. And then it is falling here. So you would say that it is increasing. I'll just write it under this word since I'm out of room. It is increasing on negative infinity to 0. And it is decreasing on 0 to infinity. Notice how you talk about it in terms of x. Your x's are negative infinity to 0 and then 0 to infinity. You're reading it this direction. So how about this one? We want to sketch this piecewise function. So we need to pick some values in each one of these intervals. So let's do less than or equal to 0. Let's just do, say, negative 3, negative 2, and negative 1 and 0. Okay, that's one section. In the next one we have 0 to 4, but not including either one. So what I'm going to do is put a 0, but I'm going to put a little circle around it because it can't exist there. Okay? And let's pick, oh, those aren't very good numbers, are they? We'll pick a 1, and we'll pick a 4, but it also can't be 4. I say that because there's no little equal to under there. Then in the last section, we want values greater than or equal to 4. So it can be 4 there. Alright, so put -3 in. What interval does it fall into? The first one. If x is 3, y is just 0. If x is -2, y is 0. If x is -1, y is 0. But what about when x is 0? Y is also 0. So what's that look like? -3, 0. -2, 0. -1, 0. And 0, 0. So everything to the left, y is always 0. So how about the next one? If this could be 0, you get the square root of 0, which is 0. Okay? If it can be 1, which it can be, you get the square root of 1, which is 1. And if it could be 4, it would be the square root of 4, which is 2. So 0, 0, it's not really there though. 1, 1, and then 4, 2, but it's not really there. That's where it would be if it could be. Why can't it be again? Because this says strictly less than 4. It doesn't say less than or equal to 4. Okay, so that's the second part of the graph. And then finally we have the last part. If x is equal to 4, look, we just get y is 2. So it actually can exist there. And then 5 you get 2, and 6 you get 2. So for everything this direction, you just get 2 straight across. So where is this increasing? It is increasing when it is rising from left to right. So it is increasing from 0 to 4. Remember, you talk about it in terms of x's. It's increasing on this interval. And is it ever decreasing? Is it ever falling from left to right? It's not decreasing anywhere, but it is constant. It's actually constant in 2 places. It's constant here and here. So you would say that it is constant on -infinity to, where did it start becoming increasing? It started becoming increasing at 0, union. Where did it stop increasing and start going constant? At 4. So 4 to infinity, it becomes constant again. So how about this one? We need some values greater than or equal to 0. So let's just do something like 2, 1, 0. And then we need some less than 0. So we want to include the 0, although it can't be there. And less than 0, we can say -1, -2. So if we plug in 2, that's here. It says whatever x is, that's what y is. So 2, 1, 0. And then for the next part, if this could be 0, you say -2 times 0 and you get 0. -2 times -1 would be +2. And -2 times -2 is +4. So what does this graph look like? 2, 2, 1, 1, 0, 0. So this side of the graph goes something like that. Then the next side is 0, 0, -1, 2, -2, 4. So this side of the graph looks something like, oops, pretend like that connects, okay? So it looks like it is falling on this side. It looks like it is rising on this side. So you don't have any constant, but you have increasing and decreasing. It is increasing from 0 to infinity, and it is decreasing from -infinity to 0.